Hi, my name is Kirk from New Phoenix Technologies, and we'd like to show you one of our latest product releases, which is a shunt kit, model number AMT 1000. It's a single function shunt kit with a shot timer, and both of these can be operated simultaneously and with only one cable to connect to your MPI device. And here, this unit is a 1% standard shunt ammeter, full wave DC, means averaging. It was calibrated for full wave DC at 50 millivolts to 1500 amp shunt. And that's what this ammeter is calibrated for. Here's your 50 millivolt, 1500 amp shunt. We also have a shot timer. And as I said, these two work in conjunction with each other. They're wired underneath the bezel. You need one connection, one cable to operate both shot timer and your ammeter, your shunt ammeter. This unit also has data out, which we'll talk about in another video. Two EE connectors, your factory calibrated certification, your brochures, other literature, and your cabling. But we just want to show you that this unit here, your ammeter, can be taken out along with your shot timer, and this is actually sold separately as a separate single function shunt kit. And this is what that looks like. This is without a timer. We also sell another version of this that uses not an LED but an LCD, and it's battery powered, and that one has an IP, or an ingress protection rating, of 67. However, these two units here, this has an IP rating, the LED model, of an IP rating of IP65, and this also is IP65. Both of these units can be purchased separately, but here we use them as a combination set, and through that we have a shunt kit using one cable that captures both current output and also shot time. So next we would like to demonstrate and just confirm the calibration of our ammeter. And now we want to confirm calibration of our ammeter for this T1000 combo set. And we can see here that we have about 50 millivolts. And we have a half-wave signal. This is our voltage and signal source. It produces full wave, half wave, and AC. And they're very clean signals. And so here we can see here we go. Okay, so we want to confirm calibration. We'll run this down to 100 amperes here. This is times 1000. So we're going to go to 3.3 millivolts, as this is calibrated for 50 millivolts to 1500 amp shunt. And here we have, we'll turn this to 3.3 millivolts. And you can see here that we have 10 times, 0.1 times 1,000 is 100 amp, and 3.3 millivolts. Now, We'll run this up to 33.3 millivolt input. And here's our cable. And we'll run this up to 33.3. And you see that we are right about 99. So we're at 990 amperes. So we can run this up to 50 millivolts, and this should be at 150. The meter should read 150. Okay, 149, it's in spec. Okay, now we'll run this up to 100 millivolt, which should be 3K, or 3,000 amperes on the meter. So we're at about 2.99, which is well within spec, well within a 1% accuracy. 2.98, well within the 1% accuracy. Let's run it up to 10K. That'll be 0.33 volts input. And this is calibrated as a means average meter, averaging meter. So there we are, we're at about 3.3. And so we're at about 97, 9.97. So that's well within spec. And let's run it up to 15K, which will be 0.500 on the voltmeter. So we can see we're about right there. 1495 to 1498, somewhere in that range. So that calibrates or verifies our calibration. And then we'll also see that run this down to about 50 millivolts. And then we can see our shot timer operate along with this, along with the ammeter. We'll have the ammeter capture. So there you go. And we're probably just a hair over 50 millivolts here. Run this up to 4.32. 4.4 seconds, 4.32 seconds. Okay, there we go. That ends this part of our video.